So Andrew has a 40% chance of being late for school in any given day. So I'm gonna say that A is the event that Andrew is late for school in any given day. And we know that Barbara has a 20% chance of the same, of being late for school. So B is going to represent the event that Barbara is late for school. So, okay, we know that those are independent events, so whether one occurs won't affect the probability of the other. And that tells us that the probability of A times the probability of B is equal to the probability of A and B. And we really only know this because we are being specifically told that events A and B are independent. So, okay, now we know that the probability of Andrew being late is 0.4 or 40%. Probability of Barbara being late is 20%, so 0.2. So the probability of A and B will be just 0.4 times 0.2, 0.08, or just 8%. So that's what goes in the middle right here. PA and B, that's the overlap. And that answers our first question, question A. The probability that Andrew and Barbara will be late for school in any given day is 8%. Fantastic. Now before I go on to answer B, I'm just going to fill out a little bit more of this Venn diagram and talk about each element. So whatever we put in here, in this area, will be the probability that Andrew's late, but Barbara isn't. And we know that probability that Andrew's late is 40%. So 40% minus 8% is 32%, and that is a probability, of course, that he'll be late, but Barbara arrives on time. Fantastic. And we know that Barbara arrives late 20% of the time. So right here, 20 minus 8, there's a 12% chance that Barbara will arrive late, but Andrew won't. Great. But, of course, these don't add up to 100%. So and of course, like, within a sample space, everything needs to add up to 100%. So we need something outside here, which will represent the probability that neither is late. They're both on time for school. How can we calculate that? Well, first, let's calculate the probability that at least one of them is late for school, which is essentially PA or B. And we can just add these elements because we have them already. 32% plus 8% plus 12%. And that will be 52%. There's a 52% chance that, or did I do that wrong? Oh no, that's right, that's right. There's a 52% chance that either will be late, or at least one of them will be late. So outside, right over here, we're going to have 48% chance. A 48% chance that they will both be on time. Fantastic. So now we want to know, that's what we wanted to know actually, that both would arrive on time. And let me quickly write that. Both arrive on time. So the probability of that occurring is less than half, only 48%. And finally, question C. What is the probability that Barbara will arrive on time, but Andrew will be late? So A is happening, and B is not happening. That, of course, will be just 32%, because Barbara is not late. 32%. That's it.